Yes, good afternoon to everyone. So today we are going to do the demonstration for experiment number 6A, 6B and 7A, 7B. Okay, fine. Okay, before that, I want to ask you one question. When you peoples were available in the college, yes, at that point of time, 8051 la interfacing experiment பண்ணோம் கரெக்டா hardware interfacing with 8051 microcontroller. Yes or no? Yes? Yes or no? Yes, okay. Okay, fine. So, which software we have used for that? Which software we have used for that? To simulate the 8051 programs, okay, and to see the result. Which software we have used? We have explored two softwares for you people. Yes, one is for writing the code, the other one is for uploading the code into the microcontroller. And you people name the softwares? Last lab session and the software use பண்ணோம் correct? Yes. Yes, very good, Anthony Surya. Rogue ISP. That software we have used for burn the code, what the code we have written and the debug. Okay, that hex file to write into the microcontroller, we have used Rogue ISP software, correct? What about the one more software we have used to build the code? Yes. Yes, very good, Anthony Surya. MCU8051 IDE. Only Anthony Surya is replying. 8051 MCU 8051 IDE. Correct? Yes. So this software we have used for writing the code. Okay, and to debug the code, error recoil and parallel, then we have simulated with virtual hardware. Okay, then one more software what we have used? Rogue ISP. This particular software we have used for burn the code into the microcontroller. Correct? Yes or no? Okay, fine. Unfortunately, some of you people are not having the laptop or desktop in your phone. Correct? Can you people reply? Who are all having laptop? You can type it in chat as laptop. Okay. Who are all having PC? You can type PC. If you are not having either laptop or PC, you can type no. Quicker type பண்ணுங்க பார்க்கலாம். உங்ககிட்ட எதுவுமே இல்லைன்னா நோன்னு ரிப்ளை பண்ணுங்க. Fine. So உங்க chat வச்சு தான் நான் இன்னைக்கு அட்டெண்டன்ஸ் எடுக்க போறேன். Who are all responding? I am going to mark it as present. Okay. For others, I am going to mark it as absent. எதுவுமே உங்கள்கிட்ட இல்லை அப்படின்னா நோன் டைப் பண்ணுங்க. Okay, fine. Fine. Okay. By considering those students who are not having the laptop or PC, desktop, okay, we have identified one particular simulator software which can be used in the Android environment. Okay. So, on my mobile phone, by installing an Android app, we can able to do this experiment. Okay. So that's the thing I want to tell you. But a kind advice to everyone, those who are not having laptop or PC, okay, second hand ஒரு laptop or PC arrange பண்ணி வெச்சுக்கோங்க, because you people are going to enter into the third year. Okay, வீட்ல டார்ச்சர் பண்ண வேணாம், financial situation பாருங்க. If it is possible, you people can have a laptop. Okay. ஏன்னா நம்ம கெரியருக்கு வந்து கண்டிப்பா லேப்டாப் கண்டிப்பா தேவைப்படும் டு ப்ரிப்பேர் யுவர் ரெஸ்யூம், வாட் எவர் இட் மே பி, பிளேஸ்மெண்ட்ல இருந்து கண்டக்ட் பண்ற எக்ஸாம்ஸ் எல்லாமே அட்டென்ட் பண்றதுக்கு. ஓகே, ஸோ இட்ஸ் அ மச் நீட்ஃபுல் திங் ஃபார் யூ பீப்புள்ஸ் ஆஸ் த திங்ஸ் ஆர் கோயிங் இன் ஆன்லைன். ஓகே, ஸோ அதை கொஞ்சம் வந்து கன்சிடர் பண்ணுங்க. பட் பேரண்ட்ஸை ட்ரபிள் பண்ணாதீங்க. ஓகேவா? கண்டிப்பா எனக்கு வேணும் அப்படின்னு சொல்லி அவங்களோட ஃபினான்சியல் சுச்சுவேஷன் புரிஞ்சுக்காம நம்ம கஷ்டப்படுத்த வேண்டாம். Those people who are able to have the laptop, you can buy. Okay, next year போனதுக்கு அப்புறம் நம்ம கண்டிப்பா தேவைப்படலாம். Sure. Okay, fine. Now we'll go with the lab session. So the very first experiment what we are going to do is addition of two 8-bit data using 8051 ALP. Okay, so that is the experiment number 6A. Okay, the same program we have written for 8085 ALP, correct? The same thing now we are going to implement for 8051. Okay, the usual lab experiment is aim is to add two 8-bit data which are available in the external RAM memory, and we have to store it back to the external RAM memory address, the result sum and carry. Fine. But in the simulator, the simulator what we are having, it is having certain limitation. Okay. See, it is not much user friendly, but we don't have any option other than that. Fine. So by considering that, we are going to use that particular simulator software. Okay. In that particular simulator software, you may not be able to have the provision of accessing external RAM memory. Fine. What about the instruction we have to use for accessing the external RAM memory? Do you people remember? External RAM memory ல data நம்ம transfer பண்றதுக்கு என்ன instruction யூஸ் பண்ணுவோம் ஞாபகம் இருக்கா? 8051 ல. Yes, very good Shivakumar. MoveX. Okay. So அந்த மாதிரி இன்ஸ்ட்ரக்ஷன்லாம் இங்க சப்போர்ட் ஆகாது நம்ம யூஸ் பண்ண போற சிமுலேட்டர். Fine. But MCU 8051 ID support all the things. Okay. Whereas the mobile app what we are going to use, it won't support the access of external RAM memory. Fine. So for that purpose, we have modified the aim of the experiment so that we are going to do the experiment on internal RAM memory only. Fine. Okay. On seeing the problem statement, you people can able to understand. Fine. So we are going to have two data, X and Y. X we term it as organ, Y we term it as addend technically. Okay. So it's a mathematical representation for the two numbers what we are going to add. The number to which we are going to add, it is called as organ. The number we are going to add, that we call it as addend. The second operator in the addition operation is termed as addend. The first operand we call it as organ. Okay. So where this organ and addend are going to be in the internal RAM memory, on seeing the problem statement, you can say. ரெண்டு டேட்டா எங்க இருக்கணும்னு சொல்லிருக்கோம், internal RAM memory location addressல இருக்கணும். What are the two addresses? The data X must be in 30H. Okay, the data Y must be in 31H. Fine. See, kindly respond. See, இன்னைக்கு CA exam முடிஞ்சிடுச்சு இல்லையா நேத்தியோட? I hope your CA exam was over by Wednesday itself, correct? But still you people are not responding. See, without you people interacting, okay, this session is not going to be an interesting one. Fine. Okay, ரெண்டு நம்பர் ஆட் பண்ண போறோம். Internal RAM memory இருக்கு. One is available in the memory location 30H. The other is available in the memory location 31H. Okay. What about the result of the addition operation? What about the result of the addition operation? When I add two numbers, 8-bit numbers, what about the result we can have? See, I am asking about the outcome of the operation. Yes, the result is going to store in accumulator only. Okay. If I add two numbers, what are the outputs we can have? Yes, very good. Sum and carry. Okay. So we are going to store the sum in memory address 40. Okay, carry in memory address 41H respectively. Fine. So we are going to perform the operation of addition of two numbers, and we are going to store the sum and the carry in the internal memory. What about the memory location we are going to store? Which memory location we are going to store the outcomes? 40 and 41H. Okay. Kindly take a screenshot of this slide. So later point of time, program எழுதுறப்ப நமக்கு இது யூஸ் ஆகும். Have you taken? Shall I proceed to the next slide? Yes, okay, fine. So before getting into the program logic, okay, we have to know some fundamental things. So then only we can able to write the program. Okay. The very first question, which register of 8051 must be used to perform addition operation? Yes, very good. So one of the operand kandipa enga irukkum sollirkom, accumulator register la irukkum sollirkom, correct? Yes. It's a very important thing we must know regarding this particular experiment. Okay. Then after addition operation, the result is available in which register? Yes. So after performing the ALU operation, the output is going to be present in the accumulator register only. Yes, fine. Okay. Next, the carry out from the addition operation can be seen in which SFR register? Number add panna sum namakku accumulator la store aidum, correct? Carry enga nama irukum, endha register la irukum? Classroom 1 la, I think Sivakumar, Anthony Surya are typing the answer. See, ஒரே ஒரு விஷயம் டாக்கண்ணா, அட்லீஸ்ட் ஆன்சர் இல்லைன்னா நம்ம ஃப்ரெண்ட்ஸ் டைப் பண்றாங்க இல்லையா, அந்த ஆன்சருக்காவது நம்ம என்ன பண்ணலாம், ரிப்ளை பண்ணலாம். See, that indicates you people are listening. See, kindly interact. What about in classroom 2? Classroom 1 la at least 3 பேர் ரெஸ்பாண்ட் பண்ணியிருக்காங்க PSW அப்படின்னு சொல்லிட்டு. Is it correct? Yes, okay, PSW. Okay, what are the flags we are having in the PSW? Do you people remember? PSW la enna flag bits la irukum? The MSB bit is carry. Yes, very good Karthikeyan, carry. Then very good Anthony Surya, auxiliary carry. Then overflow flag. Then parity, very good. So 4 flags we are going to have, which are going to indicate the status of the result. Okay, apart from that, we have some other flag bits. Okay, so that are meant for some other purpose. Okay, 4 flags: carry, auxiliary carry, parity, and overflow. So these 4 flags are going to indicate the status of the result. So here in the question I asked, which SFR we can examine? Okay, so PSW register, in that we have to examine carry flag. Okay, then coming to the instructions, it is an instruction for the following operation: to add the content of internal RAM with accumulator. Which instruction we have to use? Yes, to add the content of an internal RAM memory with accumulator. Which instruction we have to use? Okay, add A comma R. Shivakumar potukaru. Okay, Anthony Surya add and type pannirukeenga. Sajesh, you have typed the correct answer. Very good, Sajesh. Okay, add A comma R varakudaduppa. What about the convention we have told in teaching the instruction set? Yes, very good, Danya. Add A comma direct. Very good. Fine. Yes, okay. So the answer is add A comma direct. That is the correct answer. Next, to clear the content of accumulator register, which instruction we have to use? I mean, which instruction we have to use? To clear the content of accumulator, which instruction we can use? Yes, very good, Anthony Surya. What about others? Yes, CLR A. Classroom 2 la yarume respond panna maatanga. See what problem you peoples are having. Yes, very good, Dixon. As Dixon posted, move A comma has 00. That also we can use. See, I am expecting this kind of answer only from you people. Okay, see, clear A can use, or else we can go with this instruction: move A comma has 00. But only difference is clear A, it is going to occupy only 1 byte. Move A comma has 00H, it is going to occupy 2 bytes. Okay, fine. So here we are preferring clearly as it is a 1 byte instruction. Fine. Next, to add an immediate data to accumulator with carry. What about the instruction? Immediate data we are going to add to the accumulator with carry. 8085 la namakku I am specified. Yes, very good. Logos nega actually you have tried. Okay, but ADD varakuda. Instead of ADD, what we have to put? ADDC. Very good, Sanjesh. ADD space A comma hash data. That is the correct answer. Okay, so instead of that place data, we can put any values from 00 to FF. Next, to stop the program execution in Intel 8051 microcontroller, what we have to do? That's my first question. Yes. How we can terminate the program execution? No instruction we are having. Very good, Dixon. That means program order execution stop pandradhukku we don't have any instruction. So in which way we can stop the program execution? அடுத்த லைனுக்கு என்னோட program போகாம நான் ஸ்டாப் பண்ணிக்கலாம். எப்படி பண்ணலாம்? Classroom 1 ல டிக்சன் டைப் பண்ணிருக்காரு ஆன்சர். வெரி குட். What we can do? Any guess in the second classroom? See, your 80 no halt instruction here, Karthikeyan. No halt instruction. So what we can do? What kind of thing we can do? See, என்னோட microcontroller continuous work பண்ணிட்டே தான் இருக்கும். கரெக்ட்டா? halt ஆக போறது இல்ல program execution. கரெக்ட்டா? Fine. So what is the other way we can do? Any other way? Okay, reset பண்ணா என்ன ஆகும்? திரும்ப உங்க program first ல இருந்து ரன் ஆக தான் ஆரம்பிக்கும். What I need is இந்த லைனுக்கு கீழே என்னோட program போக கூடாது. So what must be that line? See, என்னோட program flow-வை change பண்ணா கண்டிப்பா நான் என்ன type of instruction யூஸ் பண்ணனும்? Branch instruction தான் நான் யூஸ் பண்ணனும். கரெக்ட்டா? Yes or no? So branch instruction போயிட்டு நான் என்ன பண்ணலாம்? ஒரு branch instruction நான் என்ன சொல்றேன்? I have to execute the same line again and again. Correct? So that's what Dixon mentioned in the class as dummy loop. Okay. So what it means? An infinite loop which is going to execute the same instruction again and again. Correct? Can you type the instruction for that? Already நம்ம 8051 lab experiment la பண்ணிருக்கோம் கண்ணா. Yes, SJMP REPEAT, repeat. Okay. Shivakumar, where you have to put the label? To which line you have to put the label? Repeat அப்படிங்கிற label எங்க போடணும்? Any guess? Very good, Danya. Yes, very good. SJMP stop. Whatever the keyword you are using, whatever the label name you are using, it must be put in the same line. Very good, Anthony. By that means we can able to stop the program execution in 8051. Okay, but hardware functionality which is it is not an actual halt operation. It is going to execute the same line again and again infinite number of times. Okay, till you press reset, it is going to execute the same line. Okay, fine. Now with this knowledge we can able to write the program for the addition. Correct? Okay, one more thing I want to tell you. As I told earlier, the software Android app what we are going to use in our mobile phone, it is having many limitations. Okay, so we have to bear with that. There is no possibility or no option for us to do the experiment in the mobile phone. Where in the app mein namak kedaikilla. Fine. So that is the only app we are having for Android app regarding 8051. Fine. So in that particular Android app, you may not able to input the data. General நம்ம என்ன பண்ணுவோம்? program எழுதிட்டு data type பண்ணிட்டு run பண்ணுவோம் program. Correct? Yes or no? We will write the program, we will enter the data, then we will execute. Correct? Here it is not like that. இங்க நமக்கு அப்படி கிடையாது. Fine. To initialize the data also, we have to write program. For example, the very first line, what we are going to use here is org 0000h. Okay. Immediately what I am going to do is, I have to initialize my data. Our program problem statement la enna sonnom? Your data X and Y are available in the internal RAM memory location 30 and 31H. Correct? Yes? Yes or no? That's why I asked you to take screenshot. Okay. So for 30H, 31H data input and runtime la kudukka mudiyadhu in the app la. So what we have to do? We have to initialize the data 1, that means X in 30 memory location. The data Y must be put in the memory location 31. Fine. So what about the instruction we can use for that? 30H la our data podum. Yes. Which instruction we have to use? I have to move an immediate data to the memory location 30H. What about the instruction we can use? Yes, very good, Sajis. Very good. Move 30H comma hash data 1. Podalama? The line nama execute panna enna agum? See, this data 1 is going to be your first number, first operand. Okay, so நம்ம problem statementல assume பண்ணிக்க சொல்லியிருந்தோம் கரெக்டா 30H ல data 1 இருக்கு X இருக்கு correct 31H ல Y இருக்குன்னு சொல்லியிருந்தோம். But here in this particular app what we are going to use, in that we cannot able to use, we may not able to enter the data in the internal RAM memory manually. So for that we are writing 2 lines of code. So what about the next instruction I have to use? What about the next instruction I have to use? Move 30H comma hash data 1 potash. What about the next instruction I have to use? Yes, move 31H comma hash data 2. Fine. Please carefully listen. These 2 lines, for what purpose we are writing? To initialize the program. To initialize the program. Okay. So என்ன பர்பஸ்க்காக நான் இதை இங்க எழுதியிருக்கேன்றதை நான் உங்களுக்கு ஆல்ரெடி சொல்லிட்டேன். அந்த ஆப்ல நம்ம மேனுவலா நம்ம போய் என்ன பண்ண முடியாது, மெமரியில டேட்டா இன்புட்ஸ் கொடுக்க முடியாது. வாட் வி ஹவ் டன் இன் 8085 மெமரி லொகேஷன் போய் டேட்டா இன்புட் கொடுத்துட்டு தென் வி வில் ரைட். கரெக்ட். ஸோ இங்கே அந்த மாதிரி ப்ரொவிஷன் கிடையாது. ஸோ ஃபார் தட் வாட் வி ஆர் டூயிங், in the program itself we are mentioning the data. Correct. So whenever you want to change the data, we have to modify the program. The first 2 lines of the program we have to modify. I hope everyone can understand what I am saying. Yes? Yes or no? Yes. Okay, fine. I will proceed. Now, I have to get the data from memory location 32 accumulator so that I can able to add. So for that what we have to do? Which instruction we have to use? I have to get the organ from the internal RAM memory to accumulator. So which instruction I have to use? Yes, very good. Yes, very good. Sajesh, yes, many of you are answering. Thank you. Okay, so move A comma 30H. That is the correct answer. Okay. Okay, now I have one data in accumulator. What about the other data? What about the other data? Data 1 இப்போ நமக்கு accumulator வந்தாச்சு. What about the other data? Where it is available? Yes, where it is available? See, data 1 30 ல இருந்துச்சு, அதை நம்ம accumulator எடுத்தாச்சு. கரெக்டா? Data 2 எங்க இருக்கு? 31H. Very good. To add that particular data with accumulator, which instruction we have to use? Yes, very good, very good. Sajesh replied. Okay, add A comma 31H. That is the correct answer. Yes. See here. Wait a minute. Slide number 5. Okay, I am following some color code. I will tell you what is the purpose of the color code. So எதெல்லாம் எனக்கு ஆபரேஷன்ஸோ அதுக்கெல்லாம் நான் என்ன பண்றேன், நிமோனிக்ஸோ அதுக்கெல்லாம் ரெட் கலர் யூஸ் பண்ணியிருக்கேன். டேட்டாக்கு I have used blue color. For RAM address, internal RAM address, I am using green color, so that you people can differentiate what I am doing. Add A,31H. What it means? We are going to add the content of the RAM memory location 31 with accumulator. Okay. Okay. After this particular operation instruction, where the result will get stored? Yes, accumulator. Okay. So what about that result? Whether it is sum or carry? Accumulator sum or carry? Yes, very good. Sum. Where we have to store it? To which memory location we have to store the sum? As given in the problem statement, we have to store the sum in 40H. Correct? So what about the instruction we have to use? What about the instruction we have to use here? Yes, very good. 40H, A. Fantastic. Okay. Then we need to store the carry. How we can do it? How it can be done? 85 நீங்க யூஸ் பண்ண அதே கான்செப்ட் இங்கேயும் யூஸ் பண்ண முடியும். என்ன பண்ணுவீங்க? 85ல கேரி பிட் கொண்டு வரதுக்கு நம்ம என்ன பண்ணணும்? Yes, very good, Shivakumar. Super. To get the carry bit to accumulator register, we have to do some dummy addition. Dummy addition means what? 0 plus 0 plus carry. இது எப்படி நம்ம அச்சீவ் பண்ண முடியும்? If you want to do any addition operation, you have to use accumulator. So first step, what we have to do? We have to clear the accumulator. Very good. We are clearing the accumulator. Okay. Now, what we can do? What we can do? Accumulator plus 0 இருக்கு. இது கூட நான் 0 with carry add பண்ணனும். So what about the instruction we have to use? Adding an immediate data 0 to accumulator with carry. What about the instruction? Yes, very good. ADDC. Yes, very good, very good. So ADDC A comma has 0H, 00H. Okay, fine. So here 00 is going to be a data. So color code namakku change aayirukku. Wait a minute. Yes, I am changing as data. Okay. Okay. So after that, if you are having carry or not, where the thing is available? Carry irundha namakku result enna varum? 01. Illana enna varum? 00. Correct? So where the result is going to available? It is available in the accumulator itself. So where we have to store the carry? 41H. So 41H ku accumulator content transfer பண்ணனும். So what about the instruction for that? Yes, very good. Move 41H, A. Fine. So what about the last line of the program? Our program is over. So by this line, we have to prevent the program execution to the next line. So which instruction we have to use? Kindly type in chat. Okay, SJMP stop. The label stop must be present in the same line. Okay, fine. Is there any other way? Is there any other way we can use to store the carry? Any other option? In the method எல்லாம் வேற ஏதாவது பண்ண முடியுமா? I will write one program that is also going to do the same thing. Okay. See, program பொறுத்த வரைக்கும் is not having any fixed logic. Fine. So org00h என்னோட program மொத்தத்தையும் நான் first paste பண்ணிக்கிறேன். Wait a minute. Control A, Control C. Okay, fine. So here, instead of I'm doing dummy addition, I can do one more thing. என்ன அப்படின்னு பார்க்கலாமா? I will type in the chat. You people see in the chat. Okay, now I am typing. Sorry, don't consider that when I am entering the program, accidentally it was posted. Wait a minute. This is skip, shift enter. Yes, NCA. Skip. Yes, you people consider this program. Will it work? And you people understand this program? So here also I am doing the clear operation. Accumulator clear pannirkom, correct? Yes. Here also we are clearing the accumulator. So after that, what I am doing? After clear accumulator operation, what I am doing? What about the instruction I have used? On seeing that program, yes. Clear A kapra enna use pannirukku JNC skip. Thank you Logus Nega. What it mean? JNC means what? Yes, very good. Jump if no carry. Meaning enna? எனக்கு carry இல்ல அப்படினா meaning என்ன? Accumulatorல என்ன இருக்கோ அது அப்படியே 41ல போகும். So what is available in accumulator after clear operation? 0 0. So இப்ப carry இல்லனா 0 போய் ஸ்டோர் ஆயிடும். Okay, we will go in this perspective. Suppose if I am having carry, what it will do? It will skip that particular instruction and move to the next line, which is nothing but INCA. INCA means what? INCA means what? Yes, increment accumulated content by 1. That's it. So what is the meaning? Carry irunda nama JNC instruction skip pannittu increment pannom accumulated content. So what about the accumulated content now? It becomes 0 1. So that we are putting into the memory location 41. Fine. But some of you people may struggle to understand this. So that's why we are preferring the same line. Kindly take a screenshot of this program. Kindly take a screenshot of this program. So the next step is we have to assemble the program. Okay. Obviously, in this particular software, mobile app, we no need to enter the opcodes, but in your observation and record material, you will be asked to enter the opcodes. Okay. So for that purpose, we are going to show you how to write the opcode for 8051 programs. Okay. So far, is 85 experiments the opcode la assemble pannom, correct? This lab we will learn how to assemble the 8051 assembly code. Okay. So whatever the program we have discussed, I have done in the tabular form. That form: address, opcode, label, mnemonics, and comments. Okay. See, on seeing each instruction, you people can understand. What about the red color is used for? Red color instruction la red color la mark pannirukku enilpa. It is going to be an operation. So it is definitely going to have opcode. Very good, Danya. Very good. So it is going to represent the opcode. Fine. What about the other things? Green color la mark pannirukku enna mean pannudpa? What about the things we have representing in green color? Yes, internal RAM memory location address, 8-bit address. Fine. What about the thing we have mentioned in the blue color? It is going to be what? Data. Very good, very good. Okay. So in the particular instruction of பொறுத்த வரைக்கும் இது என்ன ஃபார்மட்ல இருக்குன்னு யாராவது சொல்ல முடியுமா? So that you can able to write the opcode. Okay. Kindly all of you open the opcode sheet of 8051 which is posted in the classroom. Google Classroom la nama post பண்ணிருக்கோம் already. 8051 oda opcode sheet. Wait a minute. I will post the link in the class chat also. So lab related material and the topic கீழ போனீங்கன்னா you can see opcode sheet. Okay, opcode sheetல நமக்கு இன்னைக்கு என்ன இது யூஸ் பண்ண போறோம் 8051. Yes, can you people see it? Opcode sheet Google Classroom நம்ம போஸ்ட் பண்ணிருக்கோம்ப்பா. Can you people see that opcode? Yes. Do you people able to see it? Kindly respond in chat. Yes, okay. Now, can you people tell the format of this instruction? General format என்னப்பா இது? Move and address comma hash data, correct? So what about the instruction? Instruction format? Move direct, correct? Move direct comma hash data, correct? Move direct comma hash data. Can you people see the opcode for that particular instruction? Opcode sheet பார்த்து சொல்ல முடியுமா? Move direct comma hash data. What about the opcode? Yes, 75. Sajesh and Anthony Surya both are Logos Nega 75. Yes. So the opcode for the instruction is 75. What are the other things we have to mention in the instruction? As Anthony Surya type, we have to enter the opcode, then RAM memory address, then we have to enter the data. So what are the flow we have to use? After 75, what we have to do? We have to provide the address, mention the address, correct? So after 75, what we have to type? 30H. Okay, so simply 30. Here, all the opcodes are in hexadecimal, so I didn't mention H at the end. Okay, fine. So that is the RAM memory address. So followed by 30, what we have to type? 95. So by conclusion, what is the opcodes for this particular instruction? 75, 30, 95. How many bytes it is going to occupy? Yes. எத்தனை byte occupy பண்ணும் இந்த instruction? 3 byte is the correct answer. Okay. One for opcode, 1 byte for entering the address, the other byte for entering the data. Fine. Okay. Can you people say the opcode for the next instruction? First experiment I mean addition the opcode on the line by line correct. So next is the more or less remember E5 move 31H comma has 76H. Here we are considering our data are 95 and 76. If you want to give any data, you have to change the value 95H and 76H. Yes, very good. 75, 31, 76. So next is 3 bytes. Okay. What about the opcode for instruction move A comma direct? Full instruction of soliding opcode. E5, that is the opcode. Then E5 kaduthu enna type pannu 30. Very good. E5 30. Okay. What about the opcode for add A comma direct? Add A comma direct 25. Next 31. 25, 30. Correct. Okay. Then move direct comma A. What about the opcode? Move direct comma A. Yes. F5. Here F5. It's not E5. Okay. Move direct comma A. F5 and 40. Hamdan kindly correct it. Opcode sheet download panni paakrீங்களா? Okay, fine. What about the opcode for clear E? CLRA. So CLRA க்கு என்ன வரும்பா? Kindly type in chat. I'm waiting for your response. ரொம்ப நேரமா தேடுறமே ஆப் கூட. ஆண்டனி சூர்யா கண்டுபிடிச்சிட்டாங்க, தீக்ஷா கண்டுபிடிச்சிட்டாங்க. வெரி குட். E4. ஸோ நம்மலாம் கவனிக்கணும்னு அர்த்தம். ஓகே ஃபைன். நெக்ஸ்ட், what about the opcode for ADDC A, hash data? Yes, 3400. Okay. So already நம்ம move 40H, A க்கு opcode சொல்லியாச்சு, F540. So what about here? Yes, F541. Okay, a very interesting thing. Theoretically in the instruction பத்தி படிச்சோம். Short jump, which kind of addressing range it is going to use? We have studied about 3 types of addressing range regarding the branch instruction. One is relative, the other one is absolute, the last one is long range, correct? So adala idu particular edha use pannudhu, relative addressing. What is the meaning for relative addressing? For example, a new faculty who is coming to handle your class for a semester, okay fine, he know only a person in the class. Say for example, avarku pakkathula ullavara question kekanum, appo enna pannalam? He or she is going to use the person who is known to her, who is going to be a reference now. Fine. From that position, how many positions, either in the left hand side or reverse or backward or front, okay, so that he or she can able to address the other persons, correct? Yes, here we are going to use an 8-bit value which is going to tell 8-bit signed value. That's very, very important. 8-bit signed value. Okay, so using that you can able to tell the microprocessor or microcontroller how many bytes you have to jump forward or reverse. That's the meaning for it. Okay, what is the output for SJMP? What is the output for SJMP instruction? $80. Very good. $80. Okay, now it's a very important thing. You people have to know how to calculate the relative offset value. அதாவது நம்ம சொன்ன அந்த 8-bit signed number என்ன போடணும் அந்த இடத்துல எப்படி கண்டுபிடிக்கிறது பார்க்கலாமா? Okay, can you people tell me what is the address of next instruction? SJump க்கு அடுத்த instruction எந்த அட்ரஸ்ல ஸ்டார்ட் ஆகும்? Yes, it's a 2-byte instruction. Okay, 0011 la start பண்ணிருக்கோம். Fine. 0012 la இந்த instruction முடிஞ்சது. So what about the memory location of next instruction? Yes, 0013H. Fine, wait a minute. 0013H. So now it is going to be reference okay, control A, control C. இப்போ நான் சொல்ற இந்த விஷயம் எல்லாரும் புரிஞ்சுக்கணும் first. Fine. So this is going to be my reference memory location. Fine. Okay, to which address I have to jump based upon the instruction? To which address I have to jump? எந்த அட்ரஸ்க்கு நான் ஜம்ப் பண்ணி போகணும்? 0011H க்கு நான் ஜம்ப் பண்ணணும், கரெக்ட்? So that I am going to tell 0011H. branch address. So அந்த அட்ரஸ் தான் ஆக்சுவலா நான் போகணும், கரெக்டா? Yes or no? So either reference சொன்னோம் 0013 கரெக்ட்டா எங்க பிரான்ச் ஆகி போகணும் நம்ம 0011 நல்லா கவனிங்க. To calculate this offset value you have to find branch address minus reference address. கரெக்ட்டா என்ன வேல்யூ வரும் சொல்ல முடியுமா? In decimal you have to calculate. The address வந்து decimal ல கன்வர்ட் பண்ணிட்டு you have to do this. Or else hexadecimal ல பண்ணலாம், no problem. Yes. How many byte space are deviating between the two address? Zero zero one one la 0013 minus பண்ண முடியாது first of all, correct? So I will put the formula. So offset value is equal to reference minus branch address. Reference address எதுவோ அதில இருந்து branching address subtract பண்ணணும். Okay, suppose if reference address is smaller than branch address, you can do it in the reverse way and you can put minus sign, correct? Yes or no? As Anthony Surya told, there are two memory locations deviating between the two addresses, correct? There's a difference between the two addresses. Fine. How will you represent the number plus 2 in 8-bit form? Plus 2. The number வந்து என்னது? Signed number plus 2. Plus 2 or minus 2? Reference ல branch address minus பண்ணா எனக்கு என்ன கிடைக்கும் value? Oh, sorry. I have put the formula wrong. Okay, sorry. I'm sorry. Offset value is equal to, branch address minus reference. எந்த அட்ரஸ்க்கு நான் ஜம்ப் பண்றனோ அதுல ரெஃபரன்ஸ் மைனஸ் பண்ணணும். Wait a minute. Offset value is equal to branch address minus reference. I'm sorry. Okay. So branch address is 0011. The reference address is 0013. Fine. If you do this particular calculation, what will be the value you will be getting? What about the value you will be getting? Minus 2. Correct? Now, பின்னாடி தான ஜம்ப் பண்றேன். Actually next instruction தான் எனக்கு reference ன்னு சொன்னா அங்க இருந்து நான் முன்னாடி போனா நான் என்ன பண்ணலாம்? பிளஸ்ல கிடைக்கும் வேல்யூ. நான் பின்னாடி தான ஜம்ப் பண்றேன். So I am getting minus 2. Okay, what about the representation of this number minus 2 in signed 2's complement form? Signed 2's complement form, 8-bit signed 2's complement form la the number represent one. So for that what we have to find? No, Anthony Surya, you are representing in signed magnitude form. இது வந்து signed magnitude form. Logos nevo adhe dhaan pannirkeenga. Okay, very good. You people are at least trying, correct? Okay, can you represent or the value of plus 2 in binary format? Signed 2's complement format. Plus 2 ke eppadi represent பண்ணுவீங்க? So first எடுத்தோனே 2 கான binary value எழுதிட்டு அதுக்கு அப்புறம் என்ன பண்ணனும்? 8-bit வேணும்னா zeros முன்னாடி எக்ஸ்டெண்ட் பண்ணிட்டே போகணும். Yes, is it correct? Yes, plus 2 அப்படினா என்ன பண்றோம்? Yes, addition டைப் பண்ணிருக்காரு classroom 2 ல. Fine. Now you take 2's complement for this, so you will be getting the value for minus 2. பண்ணலாமா? 2's complement எடுத்தா என்ன வரும் பா இதுக்கு? For this 8-bit signed number, if you take 2's complement, you will be getting the value equivalent for minus 2. Correct? Kindly find and post in chat I am waiting for your reply. So the number plus 2 represent பண்ணிருக்கும். இது 2's complement எடுத்தா it is equivalent to, that is equivalent to minus 2. 8 பிட்டையும் நம்ம 2's complement எடுக்கணும் தன்யா. Yes, very good Logus Nega, Anthony Surya, Sajis, very good. Okay, can you represent in hexadecimal? 4 bits group பண்ணி hexadecimal எழுதுனா என்ன வரும்? FE, very good. FE. See, writing the assembly language for 8051, it's easy. To assemble the output for 8051 program is relatively complex and compared to 8085. Clear? See, FE அப்படின்ற வேல்யூ எப்படி வந்துச்சுன்னு எல்லாருக்கும் புரிஞ்சுதா? Can you people understand it? Okay. See, this part of things are taken care of by the assembler. When you are using the software, உங்களோட assembler இந்த வேலையை எல்லாத்தையும் பார்த்துக்கும், கரெக்டா? பட் இங்க நமக்கு ஆப்கோட் எப்படி எழுதணும்னு தெரியணுன்றதுக்காக தான் we are having this kind of things. Okay. So that's all about the program. Kindly take a screenshot. So உங்களுடைய ரெக்கார்ட் நோட்ல இந்த ப்ரோக்ராம் தான் எல்லாருமே எழுத போறோம். Fine. See, இதுல டேட்டாவை மாத்தி போட்டா எனக்கு எங்க மாத்தணும் தெரியுதா? 95 here you have to change it. Similarly 76 you have to change. That's all. Remaining எல்லாம் அதே தான் இருக்க போகுது. Fine. Is it clear to everyone up to this? இதுக்கப்புறம் கொஞ்சம் ஃபாஸ்டா போக ஆரம்பிச்சிடலாம். Enough time we have spent on this to understand how to assemble the output for 8051 experiment. Is it clear to everyone? The offset value கண்டுபிடிக்கிறது எல்லாருக்கும் புரிஞ்சுதா? Yes, yes, okay. What about in classroom 2? இல்ல one more example சொல்லணுமா? Shall I proceed? Or I have to tell one more example? Clear? Okay, Sajis ku புரிஞ்சிருச்சு. Fine. What about in classroom 1? Is it clear? Clear. Okay, fine. So now we will move to the second experiment. Subtraction of 2 8-bit data. So inge adhe kadha. 2 8-bit data we are going to perform subtraction operation. Okay. So here also we are going to consider the same memory location. But the operands are going to be minute and subtrahend. The first operand of the subtraction operation we call it as minute. The second one we call it as subtrahend. So minute X is in the internal RAM memory 30H, subtrahend it is available in the memory location 31H. So as a result of the difference operation, I mean subtraction operation, we are having difference and borrow, so which are going to be stored in memory location 40H and 41H. Is the problem statement is understandable by everyone? The problem statement ellarkum purinjida? Yes, okay. Now we will have the prerequisite question. Kindly take a screenshot. I'll move to next slide. Kindly take a screenshot. Yes, okay. So now we are going to discuss about the prerequisite questions for this experiment. Subtraction. When I say subtraction, where one of the data must present? Yeah, accumulator register. Okay. In the data accumulator la irukano. That is my next question. Bonus question. Minute subtrahend. Minute அப்படின்றது meaning என்ன? A number x, first number. Okay, subtrahend அப்படின்றது second number. Which must be present? Shivkumar, kindly think and answer. Minute must present in the accumulator, correct? Okay. So after performing the subtraction, where the difference will get stored? The result of the operation, accumulator only. Fine. Where the borrow can be examined? Which register? Yes, carry. When I say carry, which register? It belongs to PSW. Fine, very good. So that's all about the questions. Now we can go with the instruction. So to subtract the content of the internal RAM memory from accumulator with borrow. What about the instruction? SUBB. Do we have the instruction SUB here in 8051? No. Very good. No. So for that, if I want to perform a normal subtraction, what I have to do? Like a normal subtraction, what we have to take care? A number. Yes, very good, Andrew Surya. First, we have to clear the carry, then we have to do the operation. Okay. So what about the instruction we can use? SUBB. எதை நம்ம மைனஸ் பண்ண சொல்றோம்? RAM memory from accumulator. Meaning என்ன? SUBB A, what must come? SUBB. Yes, very good, Sajis. SUBB A, direct. Fine. Okay. So now you can write the program. இதுல எல்லாமே சேம் தான், கரெக்ட்டா? First data accumulator எடுத்தாச்சு. Fine. Minus பண்ணக்கூடிய data, I mean the subtrahend, it is available in memory location 31H. Fine. So move SUBB A, 31H. So the 31 நமக்கு வந்து address தான், so it must be mentioned in green color, marked in green color. Okay. Fine. Difference, it is going to available in accumulated register. Where we have to store? Difference எங்க ஸ்டோர் பண்ணனும்? எந்த அட்ரஸ்ல ஸ்டோர் பண்ணனும்பா? 40H. So what about the instruction? Yes, what about the instruction? Move 40H, A. Fine. For getting the borrow, that means carry to accumulator, the same procedure we are going to use. So the 41 la potachi, the last instruction it is going to be stop. SJMP stop. Label stop must be in the same way. That's all. Okay. So இதுல output நம்ம தனியா பார்க்கணும்னு அவசியம் கிடையாது. இந்த இன்ஸ்ட்ரக்ஷனுக்கு மட்டும் output சொல்லுங்க பார்க்கலாம். SUBB A, direct. SUBB A, direct. What is the output for that? Yes, 95. So what must come after 95? Yes, very good. 95, 31. So remaining எல்லாமே சேம் தான், எதுவுமே நம்ம சேஞ்ச் பண்ணல, அதே கான்செப்ட் தான். ஃபைன். ஸோ ஒரே ஒரு விஷயம் நம்ம சொல்லலாமா? ஸோ அடிஷன் ப்ரோக்ராமுக்கும் சப்ராக்ஷனுக்கும் ஒரே ஒரு டிஃபரன்ஸ் தான். ஒன்லி ஒன் இன்ஸ்ட்ரக்ஷன் இட் இஸ் கோயிங் டு வேரி. கரெக்ட். ஸோ இங்கே நம்ம யூஸ் பண்ணிருக்க டேட்டா என்ன? 37, 56. Okay, here the data what we have used is 37 and 56. Clear? So that's all about the subtraction program. Okay. Whether we will go with multiplication and division program or we can do this first, then we can go. Which one we can prefer? Majority என்ன சொல்றீங்களோ அதான் நான் ஃபாலோ பண்ணுவேன். Shall we proceed to multiplication division program? Or else we will work with simulator. You people decide. Yes, we will go with multiplication program. Okay, fine, okay. See, it's very easy only. 8051 la இந்த எக்ஸ்பெரிமெண்ட் வந்து ரொம்ப ஈஸியானதா, கஷ்டம்லாம் கிடையாது. Okay, fine. So multiplication of two 8-bit data. கொஞ்சம் கடகடன்னு பார்த்தலாம். So here also we are going to perform the operation with the internal RAM memory content. So multiplicand, multiplier. Fine. The first operand is going to be named as multiplicand. Second one we call it as multiplier. So multiplicand X inga irukudhu 30H la irukku. Multiplier it is going to available in Y. So we have to find X star Y. Correct. When I am performing the multiplication of two 8-bit number, what about the maximum size of the result? ரெண்டு 8-bit number நான் multiply பண்ணா my result may be having a 16-bit. So I'm going to split the result into two things, lower byte, higher byte. Fine. So lower byte எங்க ஸ்டோர் பண்ண போறோம்? 40H. Higher byte we are going to store in 41H. So kindly take a screenshot of this slide. Yes. Okay. Fine. So prerequisite question. Which two register must be used to perform multiplication operation? எந்த ரெண்டு ரெஜிஸ்டர் யூஸ் பண்ணும்? Yes, very good. Accumulator and B register. Okay. After multiplication, lower byte of the result எந்த ரெஜிஸ்டர்ல? Accumulator. Very good. What about the higher byte of the result? B register. That's all. இது தெரிஞ்சிருந்தா போறோம். இந்த ப்ரோக்ராம் ரொம்ப ஈஸியா எழுதலாம். Fine. Instructions பார்க்கலாம். To multiply two 8-bit data, which instruction we have to use? Very good, Andrew Surya. Mul AB. Danya, very good. Fine, very good. Mul AB. To transfer an 8-bit data from accumulator to internal RAM memory. What about the instruction? RAM memory to accumulator. Move direct comma A. Very good. Move direct comma A. To transfer an 8-bit data from B register to an internal RAM memory. Yes, move direct comma B. Actually, what about the general format of this instruction? Can you people see in opcode sheet? Do you have any instruction opcode for move direct comma B? Are you finding? Kindly check and reply me. I will have some water. Yes. இருக்கா இல்லையா அப்ப opcode sheetல move direct comma B நீ opcode இருக்கா opcode sheetல? Yes or no? No. What it mean? Actually move direct comma B அப்படின்னு நான் சொன்னாலும் what about the SFR address of B register? No need to remember that. Anyhow, I will tell you F0. Fine. The address of the SFR B register address என்ன அப்படின்னு பாத்தீங்கன்னா F0. Okay. So அப்ப நீங்க இந்த ப்ரோக்ராமை அசெம்பிள் பண்றப்ப இந்த லைனுக்கு நீங்க என்ன பண்ணணும்? Move direct comma direct. Very good, Danya. Super. Danya typed the answer. Very good. So what about the instruction format? Move direct comma direct. Here direct represent what? The first direct represents the RAM memory location. The second direct in the instruction represents SFR address. Both are going to be mentioned as direct one. Fine. So move direct comma direct is the correct answer. Okay. But புரிஞ்சுக்கணும் அப்படின்னா இந்த மாதிரி தான் நம்ம எழுதி ஆகும். Fine. So இப்ப இந்த instruction எப்படி எழுதலாம்? Move direct comma F0H. Okay. Fine. Now coming to the program. So in the line as usual நம்ம எழுதுறது தான். 30H ல data 1 multiplier, 31H ல multiplier data 2 இருக்கு. Fine. Now before performing the multiplication operation, multiplicand எங்க இருக்கணும், multiplier எங்க இருக்கணும்? Kindly type in chat. First data எங்க இருக்கணும், second data எங்க இருக்கணும்? குயிக்கா ரெஸ்பாண்ட் பண்ணுங்க பார்க்கலாம். Yes, the first data must present in accumulator, multiplicand must be in A register. What about the second data? Multiplier in B register. Very good. Okay. One thing you have to understand. Multiplication or addition of if I perform x plus y, that is equal to y plus x. If I multiply A multiplied by B, which is equal to B multiplied by A. But subtraction and division in the sequence of மாத்தக்கூடாது. மாத்தனா உங்க ரிசல்ட் என்ன ஆயிடும்? தப்பா கிடைக்கும். Fine. So as you people told, first data accumulator போகணும். What about the instruction I have to use? என்ன இன்ஸ்ட்ரக்ஷன் யூஸ் பண்ணும்பா? ஃபர்ஸ்ட் டேட்டா டு அக்குமுலேட்டர் என்ன இன்ஸ்ட்ரக்ஷன் யூஸ் பண்ணணும்? First data is available in 30H. Yes, very good. Move A, 30H. What about the next instruction? Move B, 31H. Very good. Move B, 31H. But please remember, B in portalum, we have to fill the address when we are assembling the opcodes. Okay. What about the next instruction? Yes, mul AB, very good. What about the next instruction? Lower byte of the result எங்க இருக்கும்? அதை எங்க ஸ்டோர் பண்ணணும்? So what about the instruction? சரி, நம்ம என்ன பண்ணணும்ன்றதை யோசிச்சாலே ப்ரோக்ராம் ஆட்டோமேட்டிக்கா வந்துரும். Yes, move 40H, A. What about the higher byte of the result? Where we have to store? What about the instruction? Yes, move 41H, B. Very good. So the last instruction we all know it is going to be infinite loop. SJMP, we are tagging the label to same line. Fine. Kindly take a screenshot and move to next slide. Very good. Many of you are typing the correct answer. See, in the program, basic where the two data must present before performing multiplication. So what about the result of the multiplication operation? Where lower byte will get stored, where higher byte will get stored. So this and all you people have to know it. Then only we can understand this program. Okay. Now coming to the program part, so this opcode already soliding, correct? Yes. Move A, 30 ko namakku theriyum. What about the opcode for move B, 31? Nalla gavarichinga theriyum. In the instruction format of Paakam, this particular instruction comes under, follows under which instruction format? Move direct, direct. So what about the opcode for move direct, direct? 85. இங்க தான் நமக்கு ஒரு ட்விஸ்ட் இருக்கு. என்ன அப்படின்னு பார்த்தோம்னா, ரெண்டு அட்ரஸ் இருக்கு. B registered address, then RAM memory address 31. B registered address என்ன சொன்னோம்? F0, correct? RAM memory RAM memory உள்ள எந்த கண்டென்ட் நம்ம மூவ் பண்றோம்? 31H ல உள்ளத B க்கு மூவ் பண்றோம். ஃபைன். நல்லா கவனிக்கணும். Source address, then destination address. Now you people type what are the opcode for this instruction? 85 க்கு அப்புறம் என்ன வரணும்? Source, then destination. First source address வரணும், அப்புறம் destination address வரணும். லோகஸ் நேகா டைப் பண்ணது கரெக்ட்டா? செக் பண்ணி சொல்லுங்க. Yes, 31 க்கு அப்புறம் தான் F0 வரும். கரெக்ட்டா? புரிஞ்சுதா புரியலையா? Is it clear, Logas Nega? Yes, okay, fine. Mul AB, what about the instruction? Sorry, opcode. Opcode for the instruction mul AB. A4, very good. What about the instruction for move 40H, A? Already நமக்கு தெரியும். F5 40. Okay, இதுக்கு நீங்களே சொல்லுங்க பார்க்கலாம். move direct, direct format தான் இருக்குது. இங்க source address, B registered address, destination, RAM memory address. So what about the 3 bytes? Yes. What about the opcode for this instruction? Yes, 85 F0 41. Super. 85. Why F0? Because F0 is the address of B register. Okay, then 41. So last number 80 FE. That's all. So that's all about the multiplication program. Okay. Shall we proceed with the division program? Kindly take a screenshot of this. Okay. So division program. So இங்க அதே கதை தான், அதே விஷயம் தான் சொல்றோம். Fine. இங்க divide and divisor. Divide and எங்க இருக்குது? 30H. Divisor it is present in 31H. So we have to find x divided by y. So the two results of the division operation are quotient and remainder. It must be stored in 40H and 41H respectively. எக்ஸாம்ல உங்களுக்கு இந்த ப்ரோக்ராம்ல கேட்கறப்ப ப்ராப்ளம் ஸ்டேட்மெண்ட்டை கொஞ்சம் மாத்தலாம். எப்படி கேட்கலாம்? கோஷன்ட் வந்து எனக்கு 40ல இருக்கணும், 41ல இருக்கணும், ரிமைண்டர் 41Hல இருக்கணும்னு கேட்கணும். Fine. See, you people have to understand and answer the question. Okay. See, as I told you people, ஆன்லைன் எக்ஸாம் நம்ம டிஃப்ரெண்ட் சினாரியோல கொஸ்டின் கேட்க போறோம் அப்படின்னா நீங்க கண்டிப்பா புரிஞ்சிருந்தா மட்டும்தான் இதுக்கு இதான் ஆன்சர்னு பார்த்து எழுத முடியும். Fine. Even if it is open book test, you people have to study. Don't forget that. Okay. Fine. So, logic of the program polama. அதுக்கு முன்னாடி prerequisite question. So here for performing division operation, what are the two registers we have to use? Yes, A and B. Okay. A ல என்ன இருக்கணும், B ல என்ன இருக்கணும்? டிவிஷன் பண்றதுக்கு முன்னாடி டிவைட் அண்ட் டிவைசர் எங்க இருக்கணும்? Yes, A must have the divider and the B must have the divisor. Very good, Lois. Yes, very good. Very good suggestion. Okay. So after division operation, quotient accumulator la irukum. What about the remainder? B register la irukum. That's all. Fine. So what about the instruction we are going to use here? Yes, div AB. Okay, fine. Program. Okay, யாராவது program மொத்தமும் டைப் பண்ணி chatல போஸ்ட் பண்ண முடியுமா? I will wait for some time. I will give you 2 minutes time. Okay, maximum 2 minutes நான் தரேன். Fine. Can you people type the program in the chat for this particular experiment? So first என்ன பண்ணுவோம்ப்பா? org போடுவோம். அடுத்து என்ன பண்ணணும்? We have to initialize the data. Fine. 30H la dividend, 31H la divisor போடணும். Then you have to take the dividend from 30H to accumulator. Then we have to take the divisor from memory location 31 to B register. Then you have to perform the division operation. After division operation, A register content must be put in 40H and the B register content must be put in 41H. Then finally stop the program execution. That's all. So what about the program? Entire program you people can type. Shall I wait? You people can unmute and say, otherwise your chat will be posted. யாராவது unmute பண்ணி சொல்லலாம். வெயிட் பண்ணலாமா இல்ல கண்டினியூ பண்ணிடவாங்க? I think everyone is busy in typing the program. Okay, fine. Yes, very good, Anthony Surya. Move 30H, hash 28. உங்களோட டேட்டா வந்து 28 நினைக்கிறேன். Fine. Divisor 2. Fine. Accumulator first 30 ல இருந்து டேட்டா எடுக்கிறோம். Then B register 31 ல இருந்து டேட்டா எடுக்கிறோம். Then performing division operation, moving the quotient to 40H and remainder to 41H. Stop the program. That's all. See, program ரொம்ப simple. நம்ம ரொம்ப கஷ்டப்பட்டுலாம் எழுதணும் அவசியம் கிடையாது. That's it. Very good, Anthony Surya. What about others? Yes, Sajesh. Sajesh correct போட்டிருக்காரு. Fine. Mohammad Hamdan, very good. Fine, okay. So that's all about the flow chart. Okay, programல இந்த opcode மட்டும் ஒண்ணு மாற போகுது. என்னது? Division. Correct? Div AB. What about the opcode for div AB? Mul AB க்கு A4 போட்டிருந்தோம். Div AB க்கு 84. Fine. So remaining எல்லாமே சேம் தான். ஒரே ஒரு கன்க்ளூஷன், மல்டிப்ளிகேஷன் ப்ரோக்ராமுக்கும் டிவிஷனுக்கும் என்ன டிஃபரன்ஸ்னா ஒரே ஒரு ஆபரேஷன் ஆப்கோட் மட்டும் இன்ஸ்ட்ரக்ஷன் மட்டும் மாத்த போறோம். தட்ஸ் இட். ஃபைன். இஸ் இட் கிளியர் டு எவ்ரிவன்? ஃபைன். இப்போ 4 ப்ரோக்ராமும் நம்ம எப்படி பண்றது, ஃபைன், ஹவு டு சப்மிட் யுவர் அப்சர்வேஷன், எவ்ரிதிங் ஐ வில் எக்ஸ்பிளைன். ஓகே, எல்லாத்தையும் நான் எக்ஸ்பிளைன் பண்றேன். Fine. So now I am going to disable the sorry, I'm going to stop the presentation. I'm going to present my mobile screen. Wait a minute. Sorry. Wait for some time. So அடுத்த slide போறதுக்கு முன்னாடி நம்ம presentation close பண்ணலாம். Wait for some time. முக்கியமா நீங்க எடுக்க வேண்டியது இன்னொரு ஸ்கிரீன்ஷாட் இருக்கு, அதுக்காக தான். So then we will go with the mobile window presentation. Okay. Fine. So this is a very important thing. Kindly you people take screenshot so that never you people forget what about the software we are going to use. Okay. So regarding Android mobile phone, we have to use the software, the 8051 Simulator Pro. Okay. This software is not available in the Google Play Store. Okay. Once it was available, but now it is not available. Fine. So what we are going to do is we are going to share the link to download the APK file of this particular app. Okay, don't worry, it won't create any bug in your mobile phone. Okay, so it's a free thing only. It won't create any harmful thing to your mobile phone. Okay, but when installing, it will show you a warning. Just click on settings, then just click on trust this app. Okay, after that only you will be able to install. Generally, நீங்க Play Store ல இருந்து நீங்க இன்ஸ்டால் பண்றப்ப it is verified by Google. எந்த ஒரு malfunctionம் நடக்காது நம்ம டிவைஸ்ல அப்படின்றதுக்கு they are responsible. Fine. But for this particular file, whenever you are downloading and installing APK file, you people know the procedure. Generally வந்து Play Store ல டவுன்லோட் பண்றப்ப நார்மலா இன்ஸ்டால் ஆயிடும். Fine. மேனுவலா பண்றப்ப என்ன பண்ணணும்? It will show you some warning. Fine. So the settings ல போயிட்டு நம்ம என்ன பண்ணணும்? It will ask you to recognize this as a valid software. Okay, fine. So regarding PC and laptop, you can go with MCU81 ID. Fine. So that's the thing we have used when new people came for the college to do the lab experiments. Okay, fine. MCU8051 வச்சிருந்தீங்கன்னா it's very fine. Okay, அப்படி இல்லைன்னா இந்த simulator app நம்ம யூஸ் பண்ணிக்கலாம். So regarding the observation submission as a whole, all of you must use this particular software only. Android app தான் யூஸ் பண்ண போறோம். Fine. So இதுல interfacing experiment ஒர்க் பண்ணி பார்க்க முடியாது. Android phoneல நம்ம யூஸ் பண்ண போற app. You can do only normal addition, subtraction program தான் பண்ண முடியும். Fine. Whereas in MC81 ID you can do hardware interfacing also. Fine. Okay. Now I am going to present the entire window of my mobile phone. Please wait. Wait a minute, I'm going to share. Wait, present now. Present now, a window. Yes, mobile phone screen. Sorry, wait a minute. I will present the entire screen so that I can see the chat also. Please, one of the classroom I can able to see the chat. So I will present my entire screen. So at least I will go with the chat of classroom 1, A and B class. Okay, here I can able to see the chat, and here I can able to work with my mobile phone. Okay, fine. Can you see the logo of the app? The 8051 Simulator Pro. Yes? Is the screen is visible clearly? Yes, okay. So I'm going to click on the app. The app you open panna odane, it will be entering into the portrait mode. Sorry, landscape. Automatic screen rotate. Yes. So what about the name of the app? The 8051 Simulator Pro. Fine. The 8051 Simulator Pro. That is the name of that. Okay. Now the app open panna odane இந்த மாதிரி ஒரு window வந்து நீக்கும். What you people have to do is click on delete first. No lines should be there initially. That is the first thing you have to do it. Fine. Wait a minute, the screen is changing. Fine. The next thing is click on new directive line. The new directive line click பண்ணிட்டு in the directive line we have to type org. We have to bear something with this particular software. So user friendly கிடையாது. But we are having only this software to do our lab experiment. Fine. So the directive அப்படின்ற இடத்துல நீங்க click பண்ணீங்கன்னா இந்த மாதிரி window open ஆயிடும். இங்க நம்ம என்ன பண்ண போறோம்? We have to type the assembler directive command org. Fine. Click on done. So org select பண்ணிடுறோம். Next address. Please note down address எப்படி enter பண்ணனும் அப்படினு பாத்தீங்கன்னா 0 small x followed by 40. இப்படி தான் நீங்க address enter பண்ணனும். 16-bit address wherever you are using in this particular software you have to enter the address like this. 0x stands for hexadecimal number. That's the meaning for that. 0x. Address mattum da, I mean 16-bit address mattum da in the condition. Done. Okay. So what about this line? It's a assembler command. Nama program endha line la assemble aganundradhukku nama kudukakuriya assembler command. Okay. Now we have to start writing the code. New code line. Click பண்ணீங்கன்னா எனக்கு address என்ன வந்துருச்சு பாருங்க 0000. So here we have to type the first instruction. First instruction என்ன சொன்னப்பா? What about the first instruction? To initialize the data, move. Click on done. See, ஒவ்வொரு இதுவும் தனித்தனியா தான் என்டர் பண்ற மாதிரி வரும். Entire mnemonics-உம் டைப் பண்ண முடியாது இந்த ஆப்ல. Fine. Move அப்புறம் destination. My destination is going to be 30H, but நான் இங்க 13 மட்டும் தான் கொடுப்பேன். Fine. Don't mention H at the end of the operand in this particular software. Fine. Generally எல்லா சாஃப்ட்வேர்லயும் நம்ம என்ன பண்ணோம்? Move address கொடுக்கறப்ப value போட்டு H we must put at the end, but regarding this particular app it won't support like that. Okay, move 30 comma hash data. Fine. Hash data. What value we can give? Can you people type in chat so that I can use it? Classroom A la yaradhu type பண்ணுங்க 16. Okay, so 16 I'm using the value 16. Here 16 means hexadecimal value only. Fine. Next move the next location 31. So anga na innor data kudukonum. Correct? Yes. Classroom 2 la yaradhu post பண்ணுங்க பார்க்கலாம். Second data classroom 2 la post பண்ணுங்க. I'll see the chat. Wait a minute. Yes, 32. Very good. 32. We have to put 32. Data என்ன பண்ணனும்ப்பா? Hash, it is very very important. அது போட்டாதான் அது immediate data. Now. So அடுத்த லைன் நான் வேகமா டைப் பண்றேன். Running out of time. So move A, 30. First data எடுத்தாச்சு. What about the next line? Move, sorry, add A. Add போட்டா பக்கத்துல ஆட்டோமேட்டிக்கா என்ன வந்துருச்சு? A வந்துருச்சு. The data is available in 31. New code line. Okay. So next, இங்க என்ன வேல்யூ போட போறோம்? என்ன இன்ஸ்ட்ரக்ஷன் டைப் பண்ணனும்? CLR A, correct? So CLR A. That's all. New code line. இங்க என்ன பண்ண போறோம்? ADDC A, hash 00. Fine. New code line. Move மூவ் எக்ஸ் இன்ஸ்ட்ரக்ஷன் காமிக்குது இல்லையா இதுல, பட் ஆனா சப்போர்ட் பண்ணாது இந்த ஆப். மூவ் மட்டும் தான் பண்ண முடியும். ஃபைன். மூவ். Here I missed out one instruction, so I am going to introduce a new line here. Result நான் ஸ்டோர் பண்ணவே இல்லை, கரெக்டா? So move. Destination must be 40. So அங்கதான் sum ஸ்டோர் பண்றோம், கரெக்டா? எங்க இருந்து ஸ்டோர் பண்றோம்? From accumulator. So coming to this line, move 41, A. 41, A. That's all. So program முடிஞ்சது. The last instruction it is going to be SJMP label name. Here we have to mention the label name. Stop னு கொடுக்கிறேன். So இங்க என்ன பண்ணிக்கலாம்? Stop னு டைப் பண்ணிக்கலாம். Students, understand one thing. As I am displaying my mobile screen in the desktop, okay, I can able to enter it easily. But உங்களுக்கு எப்படி வரும்? ORG click பண்ணனும், இந்த மாதிரி வரும். Next கொடுக்கணும். Then you have to give the address. Next கொடுக்கணும். Fine. So next instruction போயிடுச்சு. Move 30, click. Then you have to next click. So in that way only you have to do. அடுத்தடுத்து நமக்கு tab அடிச்சு நான் போயிட்டு இருக்கேன் சிஸ்டம்ல யூஸ் பண்றதுனால. Fine. It won't be supported in the mobile phone. So after entered all the lines, just click on check errors. Okay, the check errors நான் கொடுத்த உடனே என்னாச்சு பாருங்க, add A வந்து வேற கலர்ல இருந்துச்சு, கரெக்டா? So everything is getting proper now. Suppose இதுல ஏதோ ஒரு லைன்ல நான் மிஸ்டேக் பண்றேன்னு வச்சுக்கலாமே. For example, ADDC. Okay, ADDC பக்கத்துல நான் என்ன பண்றேன், A க்கு பதிலா I cannot able to edit here. Okay, so இல்லாத ஒரு இன்ஸ்ட்ரக்ஷன் நம்ம எழுதலாம். Say for example, ADDCC னு எழுதுறேன்னு வச்சுக்கோங்க. Fine. When I am checking error, it will show in the particular instruction highlight ஆகும், கரெக்டா? See, எந்த இன்ஸ்ட்ரக்ஷன் லைன்ல எரர் இருக்கோ அந்த particular line மட்டும் நமக்கு என்ன ஆகும், ஹைலைட் ஆயிடும். Fine. So using that we can able to understand. So that's all. Now click on check errors. Wait a minute. Delete. Yes, now the program is over. Fine. So this is the way you have to type the program. This is the way you have to enter the program in this particular app. Okay. Next, the 3 dot lines இருக்கு இல்லையா, இதை click பண்ணீங்கன்னா save to text னு வரும். Save பண்ணிக்கலாம். Fine. Experiment number 6A addition. Okay, save பண்ணுங்க. That's all. Okay, now to execute this particular program, click on run icon. First என்ன பண்ணப்பா, app open ஆன உடனே new line delete பண்ணிட்டு new directive line போட்டுட்டு then new code line கொடுத்து program full-ஆ enter பண்ணிட்டேன். Fine. So finally what I have to do, save பண்ணிட்டு we have to click on run. இந்த மாதிரி ஒரு screen வந்துரும். Okay, so all the SFRs you can able to see with the program counter. Program counter இங்க நம்ம பார்க்க முடியும். Fine. Okay, what about the value we are having in program counter now? What about the value we are having in program counter now? Yes. என்ன வேல்யூ இருக்கு பாருங்க program counterல. Kindly reply in chat. I'm waiting for your response. Yes, 0000H. Fine. That is the ORG address I have given. Correct. Okay. இப்போ நல்லா கவனிங்க, இங்க RAM location இருக்கு இல்லீங்களா, blink ஆயிட்டு இருக்கு பாருங்க. இங்க I'm going to click 30, click on OK. So what about the value I am having? 00 only. What it means? Ennoda program execution start aga. Correct. We are having 2 ways to execute the program. One is single step execution. The other one is execution of the entire program. Okay. First, we will go with the single step execution. Click on the step menu. Click panna enakku enna aidich parunga, இப்போ 30H la the first data 16 told by Anthony Surya, I think so. Somebody told the data. Correct. 16 அப்படின்ற டேட்டா யார் சொன்னதுப்பா? ஆண்டனி சூர்யா only. Okay, fine. So 30 அப்படின்ற டேட்டா வந்துச்சு. What about the value of program counter now? 0003. So what about the next instruction? In the instruction step கொடுத்தா என்ன ஆகும்? 31ல அந்த வேல்யூ ஸ்டோர் ஆயிருக்கும். செக் பண்ணி பார்க்கலாமா? 31. Okay, click on okay, then only you can see the result. Fine. Yes, see this particular simulator we are having this much provision only. At a time la நம்ம என்ன பண்ண முடியல, எல்லா மெமரியை பார்க்கிறதுக்குலாம் இங்க ப்ரொவிஷன் கிடையாது. Fine. Okay. Now next instruction move a, 13. இப்போ a registerல என்ன வேல்யூ இருக்கு பாருங்க. Before the 30 ல என்ன வேல்யூ இருக்கு? 16. Okay, accumulatorல என்ன வேல்யூ இருக்கு பாருங்க. What about accumulator? Yes, ACC ன்னு போட்டுக்கோங்களே, இதான் accumulator register 00. After executing this line, first data comes to accumulator register. Okay, 31 ல எனக்கு என்ன வேல்யூ இருக்கு? 32. Now add a, 31. 16 plus 32. என்ன ரிசல்ட் வரும்பா? 16 plus 32. What about the result we will be getting? 16 plus 32. What about the result we will get? என்ன ரிசல்ட் வரும்பா? 16 and 32 ஆட் பண்ணோம்னா hexadecimal number 16 and 32H. Kindly type it in chat. 48. Very good. 48H. Okay. So single step na கொடுத்த உடனே accumulator என்ன வேல்யூ வருது பாருங்க, 48. Now where I am going to move 40H. So 40H ல என்ன கண்டென்ட் இருக்கு? இப்போ 0 தான் இருக்கு. ஸ்டெப் எக்ஸிக்யூட் பண்ண உடனே அந்த வேல்யூ ஸ்டோர் ஆயிடுச்சு. Now accumulatorல 48 இருக்கு. ஸ்டெப் getting clear. Correct. Next ADDC space a, has 00. அப்படினா மீனிங் என்ன? accumulatorல 0 தான் இருக்கு. PSW registerல MSB bit, that is going to be carry, அதுவும் 0 தான் இருக்கு. Fine. So ADDC a, 00 பண்ணா 0 தான் வரும். So accumulatorல 0 தான் இருக்கும். That we are going to store in 41. Fine. So 41ல நம்ம போய் பார்த்தா என்ன இருக்கும்? 00. That's all. Fine. So இந்த particular instruction நான் எத்தனை தடவை ரன் பண்ணாலும் program counter value என்ன இருக்கு பாருங்க, it is not at all changing. So it is going to execute the same instruction again and again. Is it clear to everyone? Program எப்படி ரன் பண்றதுன்னு புரிஞ்சுதா? Single step. Yes. Okay, fine. Now I am going back to the program. Again program க்கு போயிட்டு நான் என்ன பண்ண போறேன்? Click on run. So இப்போ நான் full program execute பண்ண போறேன். Yes. What about the program counter now? 0x0000. I am going to run the program. Click on run. Program அது பாட்டுக்கு ரன் ஆயிட்டே தான் இருக்கும். எந்த இன்ஸ்ட்ரக்ஷன் திரும்ப திரும்ப எக்ஸிக்யூட் ஆயிட்டே இருக்கு நமக்கு? SJMP 0x0011. அந்த லைன் திரும்ப திரும்ப ரன் ஆயிட்டே இருக்கு. Fine. So I am clicking on stop. Program execution stop பண்ணிட்டேன். Fine. Kindly all of you note down this. Kindly all of you note down this. மொத்தம் 4 ஸ்கிரீன்ஷாட் எடுக்க போறோம். இந்த மொபைல் ஸ்கிரீன்ல நான் என்ன பண்ண போறேன்? 4 ஸ்கிரீன்ஷாட் எடுக்க போறோம். ஃபைன். என்னென்ன அப்படின்னு சொல்றேன். The very first one என்ன பண்ண போறோம் அப்படின்னு பாத்தீங்கன்னா 30H. அந்த மெம்பர்ல என்ன டேட்டா இருக்கு? Okay, take a screenshot. First ஒரு ஸ்கிரீன்ஷாட் எடுத்துக்கணும். Fine. So this is your input data 1. Next data எங்க இருக்கு? Where I am having the next data? Input data 1 வந்து 30 ல இருந்துச்சு. கரெக்ட்? அப்ப 31 ன்னு என்டர் பண்ணிட்டு நான் என்ன பண்ணணும்? Again I have to take second screenshot. Fine. நீங்க அப்சர்வேஷன் எக்ஸ்பெரிமெண்ட் சப்மிட் பண்றப்ப 4 ஸ்கிரீன்ஷாட் சப்மிட் பண்ணணும். என்னென்ன? 30, 31. இந்த மெமரியில உள்ள கண்டென்ட் எனக்கு விசிபிளா இருக்கணும். தென் மெமரி லொகேஷன் 40, அதுல உள்ள கண்டென்ட். தென் 41, அதுல உள்ள கண்டென்ட். ஸோ 4 ஸ்கிரீன்ஷாட் எனக்கு வேணும். 2 for your input data and 2 for your output data. Yes, is it clear? Shall we have the input so that it can have carry output? கொடுக்கலாமா? Can you suggest some data? Carry வர மாதிரி 2 நம்பர் சொல்லலாமே. Yes. You people suggest me 2 data so that I can have carry. சிவகுமார் இந்த நம்பர் ஆட் பண்ணா கேரி வராது. இன்னும் பெரிய நம்பரா சொல்லலாம். Okay, 9816 carry varad logisnega. We are performing hexadecimal number. 9 plus 1 is equal to A. Correct? A5 C6. Okay, put the power. A5 C6. So what we have to do? Here I have to type A5. Okay. There I have to type C6. Yes, that's all. So program முடிச்சதுக்கு அப்புறம் நான் என்ன பண்ண போறேன்? Then save to text. See, இந்த particular program பொறுத்த வரைக்கும் நீங்க program run பண்ண போறீங்க அப்படின்னா இந்த ஸ்கிரீனை விட்டு வெளியில வந்தீங்கன்னா டெஃபினட்டா என்ன ஆயிடும்? திரும்ப ஃபர்ஸ்ட்ல இருந்து தான் program டைப் பண்ற மாதிரி வந்துரும். சரிங்களா? Fine. These are the drawbacks we are having in this particular app. Okay, அடுத்த ஆண்டனி சூர்யா ஒரு டேட்டா கொடுத்துருக்காங்க, அதை நெக்ஸ்ட் ட்ரை பண்ணி பார்க்கலாம். Fine. So we can able to save வேணாம்னா விட்டுடலாம். Fine. Now I am going to click on run. Again I am going to click on run. Program is executing. Stop. பார்க்கலாமா அவுட்புட் எப்படி பார்க்கணும்? 30 என்ன டேட்டா சொன்னீங்க? A5. 31ல C6. Then 40ல we'll be going to have our output as 6B. Then 41ல we will be going to have the carry. Correct? Kumar, is the answer is correct? Carry வந்திருக்கு. What about my result? 6B. Is it correct? Bitwise add பண்ணி பாத்தீங்கன்னா தெரியும். Yes, very good. It's correct. Okay. Is it clear to everyone? So totally we have to take 4 screenshots. One for input data 1, next for input data 2, next for sum, next for carry. So 30, 31, 40, 41. இந்த 4 மெமரி லொகேஷனும் டைப் பண்ணி இந்த மாதிரி அவுட்புட் வரதை நெக்ஸ்ட் ஸ்கிரீன்ஷாட் எடுத்து அப்லோட் பண்ணணும் when doing your observation experiment. Okay, fine. Now we will go with the subtraction program. Subtraction program போனா எந்த ஒரு லைன் மட்டும் சேஞ்ச் பண்ணா போதும். Which of this particular line we have to change? Yes, add க்கு பதிலா என்ன போட போறோம் இப்போ? Instead of add, what we have to type? SUBB. SUBB. And now we will execute the program. Done. Run. Okay. Stop the program execution. 30 ல என்ன டேட்டா கொடுத்திருக்கோம்? A5. 31 ல என்ன டேட்டா இருக்கு? C6. So 40 ல என்ன வேல்யூ இருக்கு அப்படினு பாத்தீங்கன்னா PF. PF is the answer. 41 ல we will be having carry. Okay. I'm sorry, there is some bug in this app. When doing the subtraction operation, when I have borrow, it is not showing. Okay, wait a minute. Any mistake I have done? Kindly help me. Sub A31, 31 C6. Okay. We will put in the reverse way. Some small number we can put. 47 and begin. Okay. Then here I am going to give 36. You will see. I'm sorry. Program muttu velila vandiruchu. Na sonna illingla program muttu velila vandona again we have to type the entire code. It's going to be waste of time for us. Fine. So we don't have any other option for running the program in mobile phone. Okay. So this is the only thing we are having. So we'll type the program quickly. org 0x 0000. Okay, new code line. Move. Okay, we will go with the multiplication program now. Move 30, comma. I'm using some smaller number 4. Okay, then new code line. Move 31, comma hash 05, new port line, move A comma 30, new port line, move B comma 31, new port line, மல் கொடுத்தா அதுவே AB வந்துருச்சு, new port line, move 40, A, new port line, move 41, B, B, last line of the program. Top பதிலா நான் வேற ஏதாவது யூஸ் பண்றேன். Okay, say for example, exit, wait. So whatever the label I am using, here you have to use the same SJMP. So that's all about the program. Okay. So now I'm going to click on run. What about the outcome of 40 into 5? What about the outcome of 40 into 5? Sorry, 4 into 5. Sorry. In RAM-ML location 30, we are having the data 4. In 31, we are having 5. So what about the result we will be getting? 4 multiplied by 5. What we will get? Okay. See, 04 and 05. Kindly check. 20 நீங்க சொல்றது வந்து decimal. Okay. இது ரெண்டு hexadecimal number இருந்தாலும் 4 and 5. If I multiply 8-bit data by 8-bit data, you calculate in decimal and put it in hexadecimal. What about the value you will be getting? See, 20 அப்படின்னு போறீங்க. Okay, fine. See, what I'm asking is 20 into the decimal. Correct? See, hexadecimal number 4, அதுக்கு equivalent decimal value 4. Hexadecimal number 5, அதுக்கு equal. Yes, Sivakumar, very good. I'm clicking on run. I'm going to run the program again. Okay, start. So 30 ல என்ன இருக்குன்னு பார்க்கலாம். 30 ல என்ன இருக்கு? Okay, 4 என்ற value. 31 ல என்ன இருக்கு? 5 என்ற value. In the ML location 40, we have 14. So 41 ல நமக்கு என்ன இருக்கும்? 0. Fine. We don't have the result greater than 8-bit. Okay. Suppose இங்க நான் டேட்டா ரெண்டுமே FF னு கொடுக்க போறேன். என்ன ரிசல்ட் வருதுன்னு பார்க்கலாம். Yes, I have given us FF. Now I am going to click on run. Run the program. Stop. 30 ல என்ன இருக்கு? FF. 31 also we are having FF. In memory location 40 we are having 01. 41 la FE. So FE01 is the result. Fine. Is it clear? Subtraction ku mattum I will tell you a solution. Okay. As of now, நீங்க observation submit பண்றப்ப உங்களோட Google formல நீங்க observation output submit பண்றப்ப give data such that you won't have borrow. அந்த மாதிரி data கொடுங்க. Okay. I will identify what is the bug we are having in this particular software. Okay. Fine. When you people are submitting the observation at that point of time, don't give data which generates borrow. Okay. Coming to division operation. So division க்கு நம்ம என்ன பண்ண போறோம்? Instead of mul, we are going to put div. And you people suggest two numbers for me. Numerator number that is going to be divided. என்ன வேல்யூ போடலாம்? ஃபர்ஸ்ட் யார் போடுறீங்களோ அவங்க நம்பர் தான் நான் கொடுப்பேன். Okay, 04 dividend வந்து 04. Okay, fine. Divisor வந்து 02 சொல்லிருங்க. Very simple number. Okay, fine. So now what we have to do? We have to click on run. Again click on run. Stop it. Check the result. 30 la enna value கொடுத்தோம் 4. 31 la enna value கொடுத்தோம் 2. What about the result in 40? Quotient எவ்வளவு வரும்? Remainder என்ன வரும்பா? For this particular experiment, 4 and 2 are the input data. Fine. So 4 divided by 2 அப்படின்னா 2 times we can divide. So 2 is the answer. What about the remainder? What about the remainder? 0. Very good. Very good. 0. Fine. Any other input data from classroom 2? Can provide 2 data. We can perform the operation. Classroom 2 la x க்கு ஒரு வேல்யூ கொடுங்க, y க்கு ஒரு வேல்யூ கொடுங்க பாப்போம் சீக்கிரம். Do it fast. Okay, 40h. Okay, 40 and 8. Okay, 40 and 8. Can give 40 and 8. So here we have 40. Here we are going to give 8. Okay, I will ask you one question. What is the hexadecimal equivalent? Sorry, decimal equivalent of the number 40h? கொஞ்சம் குயிக்கா சொல்ல முடியுமா? What is the decimal equivalent value for 40h? I think it is 64. Am I correct? Yes. In decimal, 40h is equal to 64. I think so. Yes, very good. So 64 divided by 8. என்ன வரும்பா? 8. What about the remainder? 0. Check பண்ணி பார்க்கலாமா? Run. Click on run. See, எக்ஸாமுக்கு நீங்க வந்து சிங்கிள் ஸ்டெப் பண்ணணும் அவசியம் கிடையாது. ரன் பண்ணி ஸ்டாப் பண்ணிட்டு நீங்க என்ன பண்ணலாம்? 30. இது ஒரு ஸ்கிரீன்ஷாட் எடுக்கணும். 40. That is the data. 31 la we are giving 8. Then memory location 40 we are having 8. 41 la நமக்கு 8. We are getting 0. Fine. Why it is like that? Okay, we will give some other data. We will check. Wait a minute. Simple number will be 5, 2, 5, 2. Run. Stop. 40 la and 30 la enna irukku? We are having the value as 0, 5. 31 we are having 2. So 40 we must be having 2 times. What about the remainder? 1. Okay, now we are getting the data. We'll check. 40, 41. Okay, fine. There are some bugs with this particular software. Okay, I will identify what is the thing we are having in this particular software. Actually, namakku 8. Oh, sorry. Remainder 0 தான போறோம். Yes, sorry. 64 divided by 8 நம்ம பண்ணோம். So quotient 8, remainder 0. Fine. It's correct only. Okay, one more data I am going to give. So I am going to give 52. Can you people tell the decimal equivalent for this number? 52. 52 ஓட hexadecimal equivalent எப்படி கண்டுபிடிக்கலாம்? 2 multiplied by 16 power 0, 5 multiplied by 16 power 1. So 16 into 5, 80 plus 2, 82. Correct? Am I correct? ஓகே, எனக்கு இதெல்லாம் டவுட்டா இருக்கு சார். எனக்கு இது எப்படி பண்ணீங்கன்னு புரியல அப்படின்னா, இங்க 52 கொடுத்துருக்கேன் இல்லையா? சிம்பிளி நம்ம இங்க என்ன பண்ணிக்கலாம்? 10 போட்டுடலாம். ஃபைன். ஸோ ஆக்சுவலாக நான் கொடுத்த டேட்டா படி 16 by 16, சாரி 82 by 16. இந்த டேட்டாவோட டெசிமல் வேல்யூ என்னன்னா 82 by 16. பட் எக்ஸ்ட்ரா டெசிமல்ல இட் இஸ் 52 and 10. ஃபைன். இப்போ இதே வேல்யூ இன் டேர்ம்ஸ் ஆஃப் 10ல நான் கொடுத்துருக்கேன், டிவைட் பண்ணா quotient 5, remainder 2 கிடைக்குமான்னு பார்ப்போம். We'll check. Stop. Okay. Check on the data. 30 la நம்ம கொடுத்திருக்க value 52. 31 la நம்ம கொடுத்திருக்கிறது 10. So 40 5 வரணும். What about the remainder? 2. Fine. 82 divided by 16 போட்டா என்ன வரும்பா நமக்கு? Decimal la 5 times we can divide. What about the remainder? 2. 5 and 2 are the correct answer. That's it. Is it clear to everyone? Karthikeyan edo type pannirukeenga. Okay. Fine. That's all about today's experiment. So addition, subtraction, multiplication, division. Okay. All the programs we have simulated in this lab session. Okay. There are some bugs we are having in this particular software. Okay. Don't worry and don't hesitate. Okay. We can use this particular software for our end semester. Okay. So we don't have any other option for Android app to simulate the 80% program. Okay. So with this, I'm going to disable the recording of the recording.